Hi, welcome to another episode of Block Talk. I'm Chris Segura, and in today's episode, I'm going to walk you through a little bit more detailed example and usage of the Visual Studio Code extension we recently launched. I know a few weeks ago, if you're a regular viewer of this program, you saw a colleague of mine, Kale, and JT walk through the extension and talk a little bit about the basic principles, the basic idea of what our extension was trying to do, especially in terms of helping developers, whether you're a blockchain expert or you are a different developer, maybe an enterprise developer, really sort of be successful with blockchain and smart contract development, regardless of where you're coming in from. So we really wanted to make the experience sort of unified, give you a nice IDE experience using Visual Studio Code, and then help developers be productive. So in today's episode, I'm going to walk you through some of the very basics. We're going to start from basically new project, new file, new smart contract creation, and then walk you through all the way to deploying that smart contract. In future episodes, this will be a multi-part series. In future episodes, what I want to do is show you some of the more advanced features. Today, users of the extension may have noticed a few code generation pieces that do code generation for logic apps, flow apps, Azure functions. In a future episode, I'll show you how to use that. And then follow-on episodes, we'll talk about upcoming features that are not yet in the extension. We're in preview right now, but as we get towards general availability, you'll see a few more features added in to help developers interact with their contracts, debug their contracts, etc. So let's go ahead and get started. Here you see this view on the screen. This is the marketplace view of the extension. A few things to point out when you're in the marketplace. There's a wiki page here that is effectively the user guide for right now that talks a lot about the features I'm about to demo. There's a little bit of detail around system requirements. Again, we're in preview right now, so these requirements will likely relax over time. But here's the current system requirements, operating system support, etc. A couple of notes about these minimum requirements that we have seen problems with in sort of multi-operating system, multi-development environments. Python in particular tends to be a little bit tricky to install. In fact, when you install our extension from the marketplace, it looks for a few things. In particular, it looks to see if you already have a few requirements installed, Node, Git, etc. Python in particular tends to be a little difficult. You'll see here, I've set up my machine to trip the extension to say Python isn't installed properly. The problem here tends to be not that you haven't installed Python, it's when you install Python, the installer itself doesn't automatically add itself to your system path. That's a requirement, that's a need of our extension. Oftentimes, even when you've installed Python, you don't notice that checkbox is not enabled, so you don't necessarily get it installed into the system path. The FAQ online talks about how to add Python to your system path. It's not terribly difficult, but I did want it to highlight because that is the 99 times out of 100, that is the problem that people hit when they get to this. All right, so now when you go to the File Explorer view, so you go right here, sorry, turn that right off. You see a few things that the extension has installed. You see a service bar down here, and we'll talk about that in just a second. At this view, that's all you see, unless you do something like bring up the command palette. So Control-Shift-P or View Command Palette will get you a command palette. And in the command palette, if you type Azure Blockchain, you see a number of commands that have been added to the IDE. This is sort of a dynamic list, meaning right now all you see are commands that make sense given what's already created in your environment, given what you already have. This list expands or shrinks depending on what your environment looks like. So let me walk you through some of the very basic beginnings here. If you're a brand new developer, you've never created a smart contract and you'd like to just have sort of a quick start experience, the best path to do that is to do this first command here. You see New Solidity Project. If you click on New Solidity Project, you get a couple of options here. Again, for brand new developers who are maybe just learning or want to try the extension out, Create Basic Project is the path to go down, and that's the path we'll go down in a second. For those of you that are a little bit more advanced or a little more familiar with some of the open source tools that Kale described in the previous video, particularly Truffle. You may know Truffle boxes. They're effectively pre-packaged examples of various contracts. You have the option here to create a project from one of those Truffle boxes. We're not going to do that in this example, but I do want those developers out there that are familiar with Truffle to know that is the path that you go down if you click that option. Here we'll just go ahead and create basic project. Again, this is a really good example for new developers. You want to go and create it into an empty directory. You see here I already have an empty directory already created. We'll go ahead and select that project path. And right now what's going on in the background, we're using Truffle. Again, for those of you who are familiar with Truffle as an open source solution here, it is unboxing effectively a very simple project. You see here that project has a few things that are really nice for developers. We have changelog, we have a lot of the GitHub things, git ignore files, license files, a few things just to help you out that, eliminate typing, eliminate things developers typically have to do to get this added to an open source repository. We take care of that for you. We also take care of a few things here. You'll notice here we have the very beginnings of a simple Solidity project. This is a very simple example, but we've also pre-installed for you linters and sort of language syntax checking so that you can find very basic errors, right? So if I change the compiler type, you see I get a little bit of warning that things aren't right. So again, very simple helpers for developers. Here at this point, I can literally just go ahead and click on my Solidity project, right click on it, or my Solidity file, sorry, right click on it, and build the contract. Again, those of you familiar with open source tooling, this is Truffle compile, what's going on in the background. For those of you who are not as familiar with this is just building and compiling your contract. So we'll go ahead and hit that. You see it takes just a second to build. It builds two contracts. Again, the way Truffle is set up, Truffle has two contracts, a migrations contract, which helps manage contracts being sent to the ledger, and then it has your actual smart contract here. Let's go ahead and pull down just a little bit. You'll see some of the output information being put to the output channel. We're done building at this point. You see we've added a build directory. Couple of notes in this build directory. Again, if you're not familiar with smart contract development, oftentimes smart contracts have a lot of metadata that is used in various places. If you're not familiar with the ABI, that is basically like a contract descriptor. It's a JSON array that has a bunch of information. We're really trying to help developers be productive here by giving you access to that ABI automatically. So right click on your contract JSON, copy the contract ABI, and now that is in your copy paste buffer. So if you need for some reason to copy and paste that into other things, again, in future episodes or even in previous episodes, when you've seen me talk about logic apps, you might have seen me cut and paste ABIs into that. Here, again, just as a helper, we give you an easy way to get access to it, put it in your copy paste buffer and it's there. Same with things like bytecode. So now at this point, we have a contract, it's compiled. I need to deploy it somewhere. Couple of options. By default, we give you the option without doing any work to deploy this contract locally. Now, before I go ahead and deploy it locally, what that means for developers who are familiar with Truffle, we use Truffle Ganache, which is a ledger emulator, if you will. It acts and behaves like a very simple Ethereum ledger. It's installed by default. We've already configured the environment to go ahead and let you deploy this contract immediately without any work. Again, for developers who are not familiar, who are not yet ready to maybe interact with a contract in the public network or in the Azure Blockchain Service, this is a great way to just get started without having to install or create anything super complex. So right-click on the Solidity file, deploy, gives me this little pop-up tool, and if I just click development, you'll see here again in the output window, we begin the contract deployment process. I apologize. We can ignore that little error for just a second. That's a NPM version update. You see here in the output window, I get a few pieces of information coming. I get my deployment status. So you heard me mention earlier, I deploy 2 contracts actually. I deploy a migrations contract, which is a contract to help contract migrations. And then you see here finally at the bottom, my hello blockchain. This was the contract you saw on the screen. It's been deployed. Here's the contract hash. Here's the contract address if I want to interact with it. And here's a few statistics relevant to deploying in a public, or in this case, a pseudo-public environment. So that, again, super simple. I haven't really done anything but right-click and do some things. Let's do a few more advanced things before we finish up this episode in our discussion. Of course, Azure Blockchain Service is a key part of what this tool is meant to help sort of simplify and interact with. In the previous episode, you saw Kale talk about our create function here, right? So creating an Azure Blockchain Service in Azure, you can do directly from here. You get a little wizard if I were to walk through this that asks all of the questions you need to deploy this service. I'm not going to do that right now in the interest of time. I'm going to connect to an existing one. I want to walk you through this process twice, in fact, because I want to walk you through the process if you're an enterprise developer and you're integrating with an Azure Blockchain Service, how you connect to one in the cloud. I'm also going to walk through this a second time for you public developers or people who are familiar with using services like Infura. I want to walk through the process so that you see it in both ways, so that you understand it really is the exact same process. The concepts apply one for one. I want you to really see how that works. So we'll walk through this twice, again, sort of replication, but gives you an idea of how both enterprise developers and public developers use this extension. All right, so with that, let me connect to a consortium. Because I'm logged in, you see down here I'm logged in, I have access to my Azure subscription. Because I have access to my subscription, the extension knows all of the subscriptions, all of the resource groups I have access to. Here you see a previously deployed consortium. I'm just going to go ahead and connect to that. And then automatically here you see the tool has updated my service bar to include things like here's your consortium, here's my member. You'll notice a couple of things here. Again, along the lines of giving simple access to developers, we have simple access to the RPC endpoint. In Azure, oftentimes this is called the connection string. Public developers may know this better as RPC endpoint. It is the exact same thing. It is how you get to your Azure ledger via some sort of publicly accessible address. So if I were to right click on my consortium, copy the endpoint address, again, it just gets put into my copy paste buffer. And you see here very simple things of how do I get to that address. So not to spend too much time on that, but again, a lot of simple helpers for developers out there. Let's go ahead and deploy my contract to that service. So I will go ahead, right click on my contract again, deploy contracts. You see here, we've already automatically added that service to my deployment configuration. So I don't have to add any code. I didn't have to type anything. It's already there. Let me go ahead and hit Contoso. Couple of things here. If you are familiar with deploying to networks, to deploy to a network, I have to have a private key. I have to have effectively an address and a username to my network. If you've never done this before, what you want to click here is generate mnemonic. This generates a mnemonic that gets turned into a private key. If you have an existing address, you can also paste your mnemonic. If you know what that is, you could just cut and paste the mnemonic and that gets turned into a private key. You see here, I've done this a few different times, meaning I have a few mnemonics already deployed. So if I have several accounts, I can see sort of the beginning and ending first three and last three of my mnemonic there, so I can keep track of which mnemonics I'm using. For new developers, in this example, I will just go ahead and let me pick an existing mnemonic. Again, the process is super simple. I don't have to walk you through a demo. Let me pick an existing mnemonic. I don't have to do much else. It's going to take that mnemonic, create the private key off of it, and then again, you see I'm just going to go ahead and run through very similar process to what you saw me do earlier with Ganache. We're going to deploy this contract to the network. So let me go ahead and scroll down in this output window. You see we've begun the process of deploying the contract. This takes a few seconds. Lots going on in the network right now. But the output is going to look exactly the same. I am going to have a transaction hash. I am going to have a contract address. And you see here a few things. I still get the same statistics I got from the public or the Ganache deployment. The difference here is there is no real meaning to gas price in an Azure Blockchain Service. It's all set to 0. It's a private consortium. So even though I get the statistics, they're all set to 0. So that is an example of deploying to Azure Blockchain Service. Let me do this one last time and see how you use a service like Infura to deploy to a test network like Ropsten or mainnet. So you see here in the Azure Blockchain Service bar, I can right click, I can create Connect to Consortium, and in my little pull down menu, I can create a new network. I can create a test Ethereum network. And in that Ethereum network, I can name it. So let's say I name this Infura. And here in just a second, let me grab my Infura address. If you bear with me for just a second. All right, so here you see I named it Infura. Again, it's really just sort of an arbitrary name so I can keep track of which networks I have. Here I need a network location. This is that RPC endpoint address. For Infura, it is your API key effectively. Here I'm going to cut and paste a dummy one just so you see what it looks like. This one is connected to my Infura account. Again, the API key there is a dummy key. Before we go too far, a couple of notes on using mainnet or Infura. Back to the discussion we had just a second ago in using the mnemonics and getting a private key and an Ethereum address. In Azure Blockchain Service, because it's private and because you don't need gas, all of that kind of works without a lot of work. If you are a mainnet developer or you're using something like Infura and you're deploying to a public test network like Ropsten or a public mainnet, you do need the same things, of course, but the private key, that username and address, has to be funded, right? Public networks require gas. Gas requires funding. So before you go too far with this, make sure you have a key and everything that will work with your public address. All right, so at this point, you see I've added my Ropsten Rpc endpoint. I've got my Infura account. And now basically, if I want to deploy to Infura, it is the exact same process. So super simple, right click, deploy contracts. You see my new Infura address has been added there. This goes back to needing an account on Infura with funding. So this particular mnemonic here has my funding, has it's an account with money in it, effectively with ETH in it. So I go ahead and use that one. It's going to ask me some defaults for gas price, gas limits. If I just go ahead and hit select there, again, you see super simple. I'm going to go through the exact same process, and the output's going to be the exact same. You're just going to see a contract address, transaction hash, and you're going to see how much gas and how much way that I've used or ETH that I've used in my deployment. So that's it. Very simple, very easy. I hope this helped. And again, in follow-up episodes, we'll talk about some of the more advanced features of this extension. Great. Thank you for joining me.